Welcome back to Teacher Gimbel's Classroom. Today we're going to be talking about Illustrative Math, Algebra 1, Unit 1, Lesson 14, Practice. If you like this video, make sure to like it and press subscribe so you can keep getting more content like this. Let's get started. Lesson 14, Outliers, Problem 1. The number of letters received in the mail over the past week is recorded. 2, 3, 5, 5, 5, 15. Which value appears to be an outlier? So when we're looking for outliers, we're looking for values that are either way higher or way lower than the rest of the data set that we have. In this case, 15 is the highest number we have, and it's 10 away from 5, so that would be a possible outlier. We wouldn't look at 2 because 2 and 3 are very close, so that does not make 2 an outlier. So the correct answer would be D, which is 15. Let's go on to the next question. Problem 2. Elena collects 112 specimens of beetles and records their length for an ecology research project. When she returns to the laboratory, Elena finds that she incorrectly recorded one of the lengths of the beetle as 122 centimeters, about 4 feet. What should she do with that outlier, 122 centimeters, when she analyzes her data? Well, 122 centimeters will take the data and will skew the mean, as we saw in the lesson beforehand. If you need to go back to that video, pause the video now to go look at some of the lessons beforehand. So if she has a data point that is an outlier, in order to make sure that her data analysis is correct, what she should do is she should remove the outlier from the data and just do her analysis on the 111 specimens of beetles that are left. Problem 3. May took a survey of students in her class to find out how many hours they spend reading each week. Here are some summary statistics for the data that May gathered. So let's take a second to situate ourselves with the data. The mean is 8.5 hours. The median is 7 hours. The Q1 is 5 hours. The Q3 is 11 hours. And the standard deviation is 5.3 hours. I see the standard deviation is pretty high, and it means that students vary quite a bit in the number of hours that they studied. So let's give an example of numbers of hours larger than the median, which would be an outlier. Explain your reasoning. So let's think. There's a pretty simple rule that you can use to identify something an outlier. So if something is 1.5 times the IQR, so the way we write that is IQR times 1.5 plus Q3, it's going to be a higher outlier. If it's IQR times 1.5 minus Q1, then it's going to be a low outlier. So let's check out what our IQR is. Our IQR is equal to Q3 minus Q1, which in this case is 11 minus 5, which is equal to 6. So we're going to start by looking for the higher outlier, which is 6 times 1.5 plus Q3, which is 11. So 6 times 1.5 is 9, plus 11 is equal to 20. So an example of any numbers larger than the median, which would be an outlier, would be 20 hours plus. So 21 hours, 22 hours, 23 hours. So an example of a number larger than the median, let's say 22. Question number 2. Are there any outliers below the median? Explain your reasoning. So to figure out if there's something below the median, we're going to take Q1, which in this case is 5 hours, and then we're going to say our IQR, which is 6, that doesn't change, times 1.5. In this case, we get 5 minus 9, which is equal to negative 4. The lowest value we have is 0. So an outlier would have to be less than negative 4, and negative 4 and less will never happen in our problem set because there are no negative hours. So there are no outliers that will be below the median. So we're going to write down nope. Pause the video here if you need to take a second and review this. Otherwise, I'm moving on to problem number 4. The box plot shows the statistics for the weight in pounds of some dogs. Are there any outliers? How do you know? So we're going to use that same rule. And let's write it down over here. We got 1.5 times the IQR plus Q3 or Q1 minus, I wrote IQR wrong, 1.5 times the IQR. So let's go ahead and start by calculating our IQR, which is equal to Q3 minus Q1, which is equal to, in this case, our Q3 we see is 55, and our Q1, which is 35. If you don't know how to calculate the IQR, I recommend going back to some old videos and making sure that you know how to calculate it. So if I'm going to calculate this value over here, it's going to be 20 times 1.5 plus our Q3 value, which is plus 55. 20 times 1.5 is 30 plus 55, which is equal to 85. So any values over 85 will be an outlier. The only value that we know exists in this data set is this one over here. The other only value we know that exists is over here. Because this is bigger than 85, we do know that yes, there is an outlier. 95 is an outlier. And that's because 95 is greater than 1.5 times the IQR plus Q3. Let's check to see if this value down here might be an outlier. So Q1, we know, is 35. Minus 1.5 times the IQR, which doesn't change, which is 20, gets us 35 minus 30, which is equal to 5. The lowest value is 10, and the outlier would have to be less than 5. So no, there is no lower outlier. So the only outlier that we know exists in this data is 95. Again, I know this was a lot, so pause this video if you need a second to go over this question or look at it a little bit more carefully before moving on. Problem number 5. The mean exam score for a group of 20 examinees applying for a security job is 35.3 with a standard deviation of 3.6. The mean exam score for a second group of 20 examinees is 34.1 with a standard deviation of 0.5. I'm just circling my numbers to keep track of them. Both distributions are close to symmetric in shape. Use the mean and the standard deviation to compare the scores of the two groups. So let's talk about this. The mean of the first group is 35.3, and the mean of the second group is 34.1. And the mean in both groups is actually pretty similar. However, we see that the standard deviation for both groups is dramatically different. What this means is there's a lot more students that scored 3.6 or more points below 35 and 3.6 above 35. So we have lower scorers and probably higher scorers in this group over here. In this case, the standard deviation is 0.5, which means most of the students scored pretty close to 34.1. So we have a more consistent grade for the second group of students, but a lot fewer lower students and also a lot fewer higher students as well. The minimum score required to get an in-person interview is 33. Which group do you think has got more in-person interviews? Well, this group of people, we have less standard deviation, and our standard deviation is only 0.5, which means we've got a whole lot of students in this group who are going to go for the interview. We don't have a lot of students that are more than 2 standard deviations lower than the mean. However, in this group, we're going to have a decent number of students that have less than a 33 because we see our standard deviation is so large. So in this case, the correct answer is the second group of students is very much more likely to have more in-person interviews. That was a lot of theory, so if you need to pause this video to write it down, we're moving on to problem number 6. A group of pennies made in 2018 are weighed. The mean is approximately 2.5 grams with a standard deviation of 0.02 grams. Interpret the mean and the standard deviation of this context. Well, we have a group of pennies. Most of them, the average weight is 2.5 grams. The standard deviation is 0.02 grams. What this means is most pennies weigh pretty close to 2.5 grams, with some weighing 0.02 of a gram more, some weighing 0.02 of a gram less, some weighing possibly a little bit more than that, but not that much more. So the consistency of the weight of pennies is close to 2.5 with not a lot of deviation. Pause the video if you need to go back over that. Problem number 7. These values represent the expected number of paintings a person will produce over the next 10 days. So we've got these numbers over here. What is the mean and the standard deviation of the paintings? So I am going to take my numbers, I'm going to highlight them over here, and I'm going to go to my favorite staplet. We're going to not look at the weather, and we're going to go ahead and we're going to identify what type of data we're using. In this case, because we're looking at numbers and only one set of numbers, it's one quantitative value. I input my data, I'm going to begin my analysis, and I see that my mean is equal to 1.5, and my standard deviation is equal to 1.581. Let's go back to the question to see what we're being asked. We have the mean and the standard deviation. Number 2, the artist is not pleased with these statistics. If the 5 is increased to a larger value, how does this impact the median, the mean, and the standard deviation? Well, we can do that without actually trying it out. If the 5 is larger, then because this value is going to be pretty much greater than the rest of these, then it means the mean is going to get dragged to the right. Now the median in this case, it's going to stay the same because we have the same number of values. The number of values don't change. The standard deviation, that one's going to get bigger because the deviation from the mean is going to be a larger deviation when this value is considerably larger than the rest of them. So the mean and the standard deviation are both going to go up while the median stays exactly the same. Problem 8. List the 4 dot plots in order of variability from least to greatest. So we've got 4 dot plots. Well, the least variable is this one. The reason for this one being the least variable is because all of the data is the same. There is no variability. The next variability for our dot plots, and let's make this so we can see them all on one screen, is going to be the tightest graph. And when I say tight, I mean the data is kind of centered all in one area. So this guy is going to be second least. The next tightest one between these two options is going to be this one because it takes up the smallest amount of space. And then this one is going to be the most variable. Something to make sure that you're checking on these questions is make sure that the number lines are the same. If one of these was counting by 2s or 4s, or even 10s or 20s, or we had a different unit at the bottom, then we might not have exactly the same answers. But in this case, the number lines are all the same, and we've identified the least variable to the most variable. If you like this video, please put a like and a subscribe to my channel, and I look forward to seeing you in the next one.